Hey guys, great job in class today. Let's talk about the questions that you still want to see again on this review sheet. So this one's tricky because there's like functions inside of functions, and I have the natural log of something, and then inside that function is another function. So the first thing we want to do is if we take the derivative of the natural log of anything, it's 1 over what was inside. So what was inside there was the natural log of 5x. We then have to multiply that by the derivative of the natural log of 5x. So when I multiply that by the derivative of the natural log of 5x, once again, the derivative is 1 over what was inside the natural log times the derivative of what was inside there. When I clean this up, I see that these 5's are going to cancel, and I'm left with 1 over x times the natural log of 5. The instantaneous rate of change, when I see this, when I see the instantaneous rate of change at x equals 2, just think about what's f prime. Just think about it if I could write it. What is f prime at 2? So those two questions are the same. So the first thing we want to do is take the derivative. So the derivative is the derivative of the first, so we're going to use the quotient rule. 2x times x minus 1 minus x squared minus 2 times 1 all over x minus 1 quantity squared. Now we could do some cleaning up, but if it's giving us a value at which to evaluate this, f prime at 2 is equal to 2 times 2 times 2 minus 1. So everywhere I see an x, I'm plugging in a 2. So I get 4 times 1 minus 4 minus 2 is 2 all over 1 squared. 4 minus 2 over 1 is equal to 2. Okay, if I were to rewrite this question, I would have put maybe like a comma there. Then when x equals 2, dy dx is equal to, the way that the sentence should flow is that when x equals 2, what is the derivative? So if this is an implicitly defined function, let's take our derivative. The derivative of x squared is 2x plus, now this is, we have to use the product rule, so the derivative of the first times the second plus the first times the derivative of the second, and then the derivative of that constant 10 is 0. Let's get everything without a dy dx on the other side. So we get x times dy dx is equal to negative 2x minus y dy dx is equal to negative 2x minus y over x. We're only given the x value, so since we're only given the x value, we have to go back to that original to find out what the y value is equal to. When x is equal to 2, so 2 squared plus 2y is equal to 10. So now if we want to evaluate this derivative at the point 2, 3, well then I've got negative 2 times 2 minus 3 over 2. Negative 4 minus 3 over 2 is negative 7 halves. These look a little bit more complicated at first than they might actually be. So if h of x is the product of f and g, and I want to find the derivative at a particular x value, let's find the derivative of h in general. Since it's the product of f and g, then it will be the derivative of the first times the second plus plus the first times the derivative of the second. Now if we're evaluating this at 2, h prime at 2 is equal to, well, what's the derivative of f at 2? What's the value of g at 2? What's the value of f at 2? What's the derivative of g at 2? And we're given a table of values to find all of this. So when x is equal to 2, the derivative of f at 2 is 2. What's the value of g at 2? So if I'm in my g column and I go down to an x value of 2, that's 3. Plus the value of the function f at 2 times the value of the derivative of g at 2. So I get 6 plus 9, which is equal to 15. Get out of my... Okay. So same idea here. What's the derivative of h? I want everything to go over here. H prime is the derivative of the first, so f prime of x times the second minus the first times the derivative of the second all over our denominator, or the second quantity squared. Now here we're evaluating this at 1, so h prime at 1 is equal to, okay, so what's the value of the derivative of f at x equals 1? So the derivative of, I already used that color, so I'll change it to blue. H prime at 1. Okay. So the derivative of f when x is equal to 1, follow this over, 4, times the value of g at 1, 2, minus the value of f at 1, 6, times the derivative of g at 1 is 5, all over the value of g at 1 squared. So we get 8 minus 30, I'm going to write that more neatly, over 4, which is 22 over 4, negative, or negative 11 halves. Sorry, 11. I'll hold on to you for a second. Okay. The chain rule is the derivative of f at g of x times g prime of x. And here I think it's very helpful to kind of plug in that 2 so we can see what's happening. So what is f prime at g at 2 times g prime of 2? And now we can go to the table. So g of 2, the value of g at 2 is 3. What is f prime at 3? F prime at 3 is negative 4. And then what is g prime at 2? 1. So we get negative 4. This is one of those ones where they give you the function, they tell you what the derivative should be, and they want to see if you can get that derivative. So given this original function, if we go to differentiate it, 2y dy dx is equal to 0, and then the product rule, so the derivative of the first times the second plus the first times the derivative of the second. Let's get everything with the dy dx on one side. So if I get everything with the dy dx on one side, I can subtract over this x dy dx, and on the left side we'll have 2y minus x, and these both had a dy dx, so we'll factor it out. On the right side we're just left with y. Divide both sides. Dy dx is equal to y over 2y minus x, which is exactly what they gave us. To find all points on the curve where the tangent line has a slope of 1/2, we just found an equation for the slope. Our equation for the slope is y is equal to 2y minus x. And we want to know, when will that slope be equal to 1/2? You could just look at this and maybe say that, well, if x was equal to 0, then y divided by 2y is 1/2, and that would be absolutely correct. Or, if we cross multiply, 2y is equal to 2y minus x, and go to combine like terms. So to combine like terms, I guess I'll subtract 2y, and get 0 is equal to negative x, or x is equal to 0. So we found the x value for when our slope is going to be equal to 1/2. But just like in question number 5, if we have the x value, we want to find the y value. So using our original equation, this is where we can go to find points on the curve. So y squared is equal to 2 plus x times y, and we know that x is equal to 0. So y squared is equal to 2 plus x is equal to 0. So 0 times anything is 0. So when does y squared equal 2? That's when y is equal to plus or minus the square root of 2. So our points are 0, root 2, and 0, negative square roots of 2. Alright guys, let me know if this helped or didn't help, and if you still have any questions, let me know. I'll see you in the morning. It will be a very good idea to look at both that take-home on derivatives and this review sheet, and then those problems will be the ones that are on the test tomorrow. Alright guys, hope you have a great night.